Hey guys, welcome to Great Learning. Deep learning is one of the most powerful and popular domains that is helping us achieve artificial intelligence today. Since deep learning is in very high demand right now, it becomes super important that you understand the most important library that will help you create deep learning models. This is TensorFlow. Now, one of the most asked skills in all of the deep learning and artificial intelligence roles combined is TensorFlow in itself. Keeping exactly this in mind, we here at Great Learning have come up with this comprehensive TensorFlow tutorial that will help you get started with deep learning using the library. We will also discuss a good amount of theory followed by an ample amount of practical demonstrations to help you concrete your understanding. With that, I know you guys are super excited to get started. Well, what are we waiting for? My name is Anirudh Rao. Let's get started. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments. So alright guys, coming to the agenda of this TensorFlow tutorial, it becomes super important that we try to cover as much as possible to make sure that if you guys are beginners trying to get started with TensorFlow, you have a well-rounded understanding of it, right? Now to do that, we're gonna have to start out by taking a look at understanding what TensorFlow is, right? So we'll take a good introduction to just check out what TensorFlow is, why would we even require it, and first of all, why is it so popular, right? Now after we understand these concepts, you'll be very curious to understand what are some of the entities that help in the functioning of this library, right? Now tensors are a very important thing that we're gonna have to discuss. So let's understand what they are, where they're used, what are the types of tensors there are, and a lot more as well. Now, once we understand a little bit of TensorFlow, once we understand what tensors are, the most important thing that you guys can do is to actually get started by setting it up on your machines and probably writing code side by side as I do, right? Now, to do that, I'm going to also guide you on how you guys can go on to install TensorFlow by yourself. Well, it is super easy and it is simple and straightforward, right? Now, once we go on to install TensorFlow, you will require a small amount of understanding to know where TensorFlow is effectively used, right? It's in the domain of artificial intelligence, deep learning, neural networks, and more. So we'll have an understanding to that. We'll take a quick introduction to figure out what neural networks are, how they work, and of course, even understanding the mathematical concepts that are used in the backend that helps us get towards AI and AI related models, right? So we're going to take a look at all of that, and after we check that out, we're going to be actually diving right into TensorFlow, understanding a bit about how it is used, where can you use it, and of course, right, since we'll be covering a good amount of theory, it always adds value that you guys complement it with practical learning, right? Now, keeping exactly that in mind, we are also going to take a look at two super important practical sessions, guys, two hands-on sessions where we'll be taking a look at classifying two important things. Now, when we get to that point, I am sure you guys will have a comprehensive understanding of how TensorFlow works, why it is popular, and more so when we dive right into the demo. If you guys can work with Python syntax, you will find it super easy to understand the flow, right? Now, the syntax is pretty common for most of these cases, but the actual application varies based on what it is that you're trying to do. Now, guys, without further ado, I think let's just dive right into our first concept here, which is introduction to TensorFlow. Now, ladies and gentlemen, what is super important here is that you have to understand what TensorFlow is, why did it come into the picture, and why are we even using it today? I take an approach to understand saying, hey, where would we be? What would we do if we never had TensorFlow today? And that we're going to discuss in this section as well.
right? Now, to give you a little background story about how TensorFlow itself came into the picture, now what happened is that a couple of years back, developers were hunting around for a library which basically makes it super easy for the developer to actually go on to use and understand and try to figure out what is the best way that they can use to effectively solve deep learning challenges out there, right? Now, Python offers very good syntax to go about doing this, but you have to understand that a language such as Python, right, it gets all of its powers by these beautiful libraries, which eventually make your life as a developer super easy, right? Now, you can have a lot of functionality. That doesn't mean you have to write a lot of code, right? That is why we have functions. That is why we have helpers. That is why we have frameworks, libraries, toolkits, so much more, right? Now, TensorFlow belongs to one of these categories, which eventually help us get to that point. Now, if you've clicked on this video, I assume that you guys are aware of how to work with Python. You know the basic Python syntax and maybe even basics of neural networks, right? Now, what is more important for you guys here is that knowing that TensorFlow is a deep learning library, first of all. Second of all, its popularity comes because there was this huge initial demand, as I just mentioned, right? Developers and especially researchers, right? Now, any of these big libraries that have become super popular, if you actually trace it back to its roots, it would have been a research problem which eventually became commercially available, right? Now, in this case, there is a specific thing that's mentioned on your screen right now. Developers were looking for open source solutions. In the world of programming, ladies and gentlemen, or in the world of deep learning and AI, if you try to use niche products or closed-ended products, what happens is that you're limiting at least 70% of your audience in terms of reach. Not all the people would love to pay for a product which eventually someone else might give it in terms of open source for free, right? So of course, you have to understand that Google, being the top giants that they are the ones that are behind TensorFlow, right? And of course, they decided, they used it, they created a beautiful prototype and in fact a working version of TensorFlow, and they eventually put it out to the world. And it is so well optimized. It makes your job as a developer to such an easy extent where at the end of the day, if you're trying to solve a deep learning problem, your head and your important logical space will eventually be to just try to figure out the problem rather than think about any complex syntax that might follow there, right? That makes this library, that gives power to this super amazing library, in my opinion. First of all, it is open source. Second of all, it is really powerful, because when you take a look at any other library, we have one or two that stands up to TensorFlow, and they're good at what they do. But when you're thinking about a general tool which works for researchers, students, which works for IT professionals, which works for beginners, works for experts, and more, if you just have all of these requirements at once to cater to it, eventually we have TensorFlow, right? Now, what happened is that, let's quickly go back 5 years down the line. We are at 2021 right now. If you take a look at 2016, right? In 2016, the Google Brain team actually released the TensorFlow. Now, the Google Brain team is renamed to the Google AI team now, but you have to understand that this is a team which is responsible for the most innovative artificial intelligence based applications from Google, right? So whenever you think about any of their G Suite products, which is super well tuned, be it the Google Assistant, be it Maps, be it anything else, this team has a good amount of contribution there. Now, what happened in 2016 was, again, when the world was looking for a library and it was hugely in demand, Google stepped up to the challenge and said, hey, we have a prototype, here's a version that you all guys can use, and it was open source as well, right? So in 2016, when it was completely free to use and open source to use, I remember very well that a lot of people just started hyping this up. Now, as a person who's working on data science, who's working on deep learning at that time, I was super interested to see what all the hype was about. So I myself installed TensorFlow. I was taking a look at their documentation, and I was blown away by the amount of simplicity and at the same time how powerful this library was, right? All the contributions, in fact, I want to say most of the contributions that that we have in today's world, where Python and deep learning might have been used, there's a very good chance TensorFlow had something, either a small part in it or it had a huge role to do, right? So that is super amazing, because we have millions of AI based applications with millions of ideas cropping up every single day. Knowing that the demand is virtually endless for our hunt of artificial intelligence in the future, we have a library which is very strong, and its foundations are really strong to take us probably 10-15 years into the future, right? That is how well TensorFlow is coded, that is how well TensorFlow is written, and again, it speaks to its popularity, right? So the Google Brain team came up with it in 2016 to give you guys a bit of history. Now, what happens is that when you think about TensorFlow as a library, as a framework, you have to understand what it is exactly, right? Now, TensorFlow gives you the ability to emulate neural networks by making use of Python code. Now, when I say emulate neural networks, the term neural networks itself came from us actually trying to understand how the neurons in our brain work and try to get our computers to do something on the same lines of it to, of course, make it intelligent as us, right? Now, to do that, they required one simple library to do, and TensorFlow catered to it. It's a very powerful open source framework for deep learning that works really, really well in Python. Now, you might be asking a question at this moment of time saying, hey, can TensorFlow be used with other programming languages, or is there a compulsion which says, hey, if you have to use TensorFlow, you have to use Python? Is that the case? Well, to answer that particular question, it is not just Python that is used for TensorFlow. Now, TensorFlow is a fantastic library which will work, well, of course, it is built to be used with Python, right? Now, there are many reasons of why TensorFlow would want to work really well with Python, because of how Python works in its fundamental sense, and TensorFlow was made to talk with a popular language, right? It was built with a purpose to make sure it is as effective and efficient when speaking to Python. But this does not mean that it will not work with other programming language, right? There is multiple third-party support that is provided for programming languages such as C#, MATLAB, a super popular data analysis programming language called as the R programming language, and the last one that you see on your screen right now is a programming language called Rust, right? So not just Python, there are 5 or 6 other libraries, 5 or 6 other languages where you have complete usage of TensorFlow, but then of course official support is only provided to Python, because again, you cannot just have one library and it takes a lot of development to make TensorFlow what it is, right? So making sure that you're focusing the developers to work on making that tool the ultimate one-for-one programming language, I think that is what Google were aiming for, and that is exactly the result that we see today, right? So now we know what TensorFlow is, now we know when it came about, who's responsible for TensorFlow, and what programming languages can be used, right? Now, since you guys are watching this video, let me know which programming language is your preferred one in the comment section below. I believe that most of you will say Python is your preferred programming language, because at the end of it, again, Python's popularity rose really well. Alongside that, to mirror it, TensorFlow's popularity was going up and up and up as well, right? People realize the power of Python. People realize that TensorFlow is a library that makes your life super simple by giving you fantastic syntax to work with. Eventually bring it together, you have a very well-rounded product, right? Pretty simple and straightforward. But the most important thing that we're trying to answer with this is, why is the name TensorFlow? What does a tensor even mean? Does it have any meaning? Flow is okay. Flow is an English word, but what is a tensor, right? You might have not heard of the name. If you have, well, here's a quick refresher for you guys as well. Now, one thing you guys really have to know here is TensorFlow got its name basically because of two things. One is tensor, the second part of it is flow. Now, when we speak about tensors, tensors are nothing but multi-dimensional array structures, a very specific type of data structures which are required to create nodes in a neural network setup, right? That's the reason why there is a name tensor. But what about the flow? Why is there a flow of tensors tensors there? Well, to answer that question, when I say flow, basically how a simple neural network works or how a tensor itself works is that we take multiple numerical computations and we convert it into something called as computation graphs. These computation graphs is what denotes the flow of numerical data in the form of a network, right? When you have the data flow, that is where you've got the name flow. So when they just picked up the idea of tensors, when they realized computation graphs and data flows, they just brought it together, hence the name TensorFlow, right? It is very easy to understand and remember this. And if you're a beginner who might be looking forward to learning TensorFlow as well, there's a very good chance this might be asked in an interview to see to what level of depth you might have had, you might have researched with respect to TensorFlow, right? Now, when you're thinking about a neural network itself, it becomes important that you understand what is required to get the neural networks to work. Of course, we have a section where we are going to be discussing the same thing. Now, to give you a bit of clarity, I just told you that there are nodes which are used to create a neural network, and to calculate and give you an input output for these nodes, we have something called as tensors. So it is very simple to understand that tensors are these little blips. Tensors are these little data storage entities which will eventually give some sort of storage, understanding, meaning, and a network flow wherein data can move around in the network, and eventually you can go from just having data or maybe raw input all the way to having a popular output, right? That is important for you guys to understand here. Well, now we are also clear with how the name of TensorFlow came about, so it becomes very, very vital that we take a moment to understand what these entities called tensors are. I told you that they are multi-dimensional data arrays, but one very important thing we have to talk about before we understand what tensors are is the prerequisites, right? Now, there are certain prerequisites for you guys to learn TensorFlow, for you guys to understand these tensors and their working as well. Now that we we understand that there are certain prerequisites, what are they? Well, it's simple. Look at your screen right now. I have three simple prerequisites for you guys. One is linear algebra, the other one is vector calculus, and the third one is Python syntax. Let's talk about the Python syntax part first. As I told you, TensorFlow and Python are super popular when they work together, and they work fantastically well. So it becomes absolutely obvious that you are going to require some experience working and writing syntax on your own with respect to Python, right? That is required to understand how a tensor works, how you guys can go on to create your own tensors and perform some operations, right? Tensor operations are super popular. In fact, I'll show you a demo where we'll be performing the tensor operations as well, right? Now, Python side of it is very clear by this point of time. But what about linear algebra and vector calculus? Why do we require these mathematical concepts when we are writing code in Python? That's a very good question. Now, when you're using tensors, there are two things you have to understand. One is understanding the procedure for you guys to create and use and work with tensors. That is very simple. You can learn it just like you're learning another language, right? Maybe you want to move to Germany, you can sit and learn German, and you can do it pretty quickly as well, I suppose, right? Similarly, that is the case. But do you know how tensors work? When I say how tensors work, it is not how the Python syntax for tensors work. It is the actual working of the entity tensor, right? So to understand that, there are many, many mathematical concepts that govern this world. Linear algebra, the concepts of probability, the concepts of permutation, the concepts of understanding how you can work with calculus, how you can work with integration, a little bit of differentiation. All of these are required on the back end. Now, when I tell you guys this, you might ask me a question saying, hey, are these required if I have to get started with TensorFlow right now? Well, to get started, and I know this, all of you guys will be super excited to just think about writing your first piece of TensorFlow code, getting started right about, and finishing your first AI-based data solution, right? Well, we will get to that point. We will discuss multiple demos, as I just told you guys. But understanding how some things work will help you not only solve the problem, and in fact solve the problem quicker, but at the same time, you will also have have the complete understanding to tweak your problem. You will have the understanding to maybe find different solutions to the same problems if you understand how it works. It is a very simple thing, guys. If you have a car and you just drive it around, fantastic. But if it breaks down, you'll have to take it to an expert, right? But what if you know how to fix your car if it breaks down? It's simple, right? You bring it home, you fix it up, and you start driving. Now you know how to drive around a car. Now you know how to fix the car. So you have better overall knowledge about the working of your car itself. Exactly the similar thing. So make sure while you're concentrating on Python syntax, you have to also take a look at understanding these two concepts, algebra and calculus, right? It's fine. You don't need a very in-depth knowledge of it, but some basic knowledge of how things work mathematically is required. And in fact, we're going to be discussing the mathematics behind how a neural network works as well in the next couple of sessions. But coming back to the main point of discussion here, we are discussing what tensors are. So let me give you a quick picture, a quick understanding of how you can work around the way of tensors and how you can wrap up things here, right? Now, think of three things, ladies and gentlemen. When I say I am 6 feet tall, it basically is a scalar value, right? 6 feet is a number. Now, if I just say, hey, I have a scale which is 30 centimeters, the usual long scale that we get, correct? If I say that is 30 centimeters, well, it is just that. There is no angle to it. There is no, basically there is no relative angle to it, right? Now, one important thing you have to understand about scalar values is that they will have no direction. They'll only have a quantity. They'll only have a value. Now, if I say, hey guys, I am 65 kilos, I weigh 65 kilos or something around that. Of course, I don't weigh 65, but that's not the point here. Now, when I go on to say that, that number that I just said, 65 kilos, does it require a direction? Now, I know some of you all sciencey guys out there might say, yes, you require gravity, you require the downward direction. Yes, I understand. That's the concept of weight. Let's just think about the concept of mass, right? So, it's a number. If I just give you my phone number, it's again just the number itself, right? It's a scalar. There is no direction to a phone number. There is no direction to a date of birth, for example. But when you take a look at numbers such as vectors, now vectors are super important because here, not only will you get the length of the line or the length of the thing that you're measuring, you will also get the direction of which you guys are moving around, right? Because in the case of vectors, length will usually remain the same. What changes is the way in which the direction moves around for that, right? Now, the way your car wheels move on the road is considered as a vector because you can track the distance that the car moves. You can also track the direction that the car moves in, right? That is the simple difference between scalar values and vectors. Now, to give you a specific example of where I say when we talk about relative directions, it's simple. You just find a reference point, right? Now, if I say, hey, I am 6 feet tall. Now that the sciencey guys are here, if you take a look at it in detail, what will happen is that when I say I'm 6 feet tall, if I stand next to a wall, if I measure 90 degrees from the ground, I will realize that I'm 6 feet tall. Maybe if I just measure it from my side, it'll absolutely not make any sense. It'll just be another scalar, right? If you want the accurate value, you're using a relative direction to measure what? Your length, your height, something like that, guys. So this is very important for you to understand because tensors are nothing but objects which use the similar kind of concepts in terms of vectors and everything around them. So what are these tensors? How can you understand them in the most simple fashion? Now, when we are working with any sort of mathematical concepts, it is very important that you have inputs and you have certain operations that goes on with these inputs and you have certain outputs as well, right? Now, when you take all of this, you will have an output from a mathematical solution. And in the case of Python, in the case of TensorFlow, we're going to be considering that as an object. Now, when you have an object, you want to add meaning to this object. What do? You give the object a purpose. In this case, what we try to do is we try to associate this object with the vector space around it. Now, when we have a mathematical entity as is, it will not make sense. If I say 5, just 5, Does it make sense? There is nothing to give you a match of what 5 is. Now, if I'm being very specific, if I say 5 centimeters or 5 meters or 5 kilometers, now you have an association of not just the number or the quantity or the object, you have that in relative distance with other things as well. Tensors work the exact same way. We take an algebraic approach. We have an object there and we try to map this object with respect to its surroundings, with respect to the space that it can move around freely. And once we go on to do this, they are called as tensors, guys. So this relationship that we have between these objects and the relationship that talks about not just the objects, but the objects and the space around them, that eventually gives it its entire meaning. This is tensors, guys. That is a very, very simple way to understand what they are. To reiterate on one important thing, you might have read about, if you're talking to someone about TensorFlow, you're doing some of your own research, there is something where you would have heard of something such as rank of a tensor, so a dimension of a tensor, right? Of course, tensors can be of 3 dimensions, guys. 1 dimension, 2 dimension, and 3 dimension. Now, you guys head to the comment section and you give me an example for something which is in 1 dimension, something which is in 2 dimensions, and of course, an example for anything that is in the 3-dimensional world that we live in as well, right? Now, one important you have to understand about scalars is that we'll only require one number to basically give us any dimension that we want. As I just told you, right? 10 meters. Done. That's a scalar that eventually you'll only require 1 meter, even though it's a very specific scalar. If I just say 10 meters, that is everything you're going to need to understand anything that's required about a scalar. But if it's a vector, I'll say, hey, it's 10 centimeters tall when you measure it from the ground at a 90-degree angle. Now it's a vector, right? But what about a tensor? Scalar done, vector done. For tensors, where when we talk about a rank, when we talk about these dimensions, you will basically require n power r, wherein r is considered as the rank of a tensor. Now, when you're working with a 3-dimensional object, 3 power 1 is a rank is a rank of a tensor 1 in the 3-dimensional space. It's a 3-dimensional. I'll repeat it. It's a 3-dimensional tensor which basically has the rank of 1. Now, what is 3 power 2? It's a 3-dimensional tensor which has rank 2, right? 3 3s is 9. Now, when you take a look at adding these ranks, your tensor becomes more and more complex, and eventually it becomes super important for you to understand the dimensionality aspect of it. The amount of structured data that you can store in a tensor will just go up and up, right? If you have n dimensions and you have you know what is the rank that is required to achieve data storage for those many dimensions, it's pretty simple. Just use the formula n power r, understand the amount of data, understand the logical bits that can go into storing data into the tensors, right? Fantastic. Now that we know what tensors are to a good amount of degree, you will be very curious now to actually get started, right? As I told you, when I was learning TensorFlow all those years back as well, the very first thing I wanted to do was, hey, show me the code. I want to start writing code. Now, I know you guys are equally excited to get to that point, but one important thing you have to realize is how you guys can go on to install TensorFlow. So how do you install TensorFlow? Is it complex? Sometimes installing Python libraries can be a hassle. So is it the same thing here, or is it very straightforward? The answer is the latter. It is super straightforward to go on to work with tensors. One very important thing you have to understand is that everything that you need to install TensorFlow, everything you need to install Python, everything you need to make Python talk to TensorFlow are all open source, are all absolutely free of cost. Again, for personal use, commercial use, and all of that as well. So everything that you need is available in one simple place, which is nothing but the TensorFlow official documentation. Now, what we are going to do is, let's just take a look at the steps on your screen, and eventually we'll go and get started with how you guys can install it, right? The first step, of course, is to head to the official site and understand what the latest version is and the compatibility for it, right? Now, what I am going to do here is, I have the browser open. I'll just type in TensorFlow in Google here. Now, as soon as I click the official website is TensorFlow.org. Let me just get to their website. And in fact, TensorFlow is one of these libraries which is documented so well, right? Just like any other Google product, they have a ton of documentation. They have a huge community. In fact, they have a small section wherein you can try to understand TensorFlow for its various usage. If you want to use it with JavaScript, if you want to use TensorFlow for mobile applications and all of that, right? You can see from these tabs that you can understand a lot about it, and it is even clear for a beginner to understand why it's required, right? As soon as you go on to open TensorFlow's page and you're scrolling down, they'll just show you why you have to prefer TensorFlow. Now, TensorFlow is from Google. There is one more competition element which is eventually super popular, as popular as TensorFlow, which is nothing but PyTorch. PyTorch is a fantastic deep learning library which is developed by the creative developing team at Facebook as well, right? So TensorFlow is from Google, PyTorch is from Facebook. Now, they'll give you some of these reasons of why you should consider TensorFlow, right? Easy model building. You can go on to work with machine learning production. You can have fantastic power when you're trying to find insights based on research, right? You find so many different things right here on their website, which will eventually help you understand TensorFlow. You can find out a lot about these companies that are using TensorFlow as well. So guys, moving around the TensorFlow site, you find a lot of information, right? Everything from the case studies that are solved using TensorFlow and who uses TensorFlow as well, right? Ladies and gentlemen, look at your screen right now. I wanted to put all of these in my slides itself on the PowerPoint to show you guys, but again, it just becomes a hassle because you cannot fit all of these companies. Now, just find the net worth of all these companies that are shown on your screen and you will understand that it's trillions of dollars, right? Trillions and trillions of dollars in discussion. So it becomes vital that you understand everyone from a company such as Coca-Cola, GE Healthcare, Intel, Bloomberg, Lenovo, Snapchat, and of course PayPal, Nvidia, right? Now, some of these tools from these companies we use daily, but you have to understand that it is super popular right now. When these companies are using it, it is a trickle down to other mid-tier companies and mid-sized companies saying, hey, if these guys can make it work on an enterprise level, let us also give it a try. Now, when those guys do it, people who are entrepreneurs, startups, these guys are also super interested, saying, hey, if it's so powerful and easy, and if these guys can do it, we can do it too. And if they're doing it, students can do it. If every one of these guys can do it, it's because of the research that goes into it, right? So you'll find a ton of stuff. I love browsing around the TensorFlow website here, and you can find out so many things. The most simple and straightforward thing that we have to discuss right now is the ability to install TensorFlow. Alright guys, so hitting this install tab is basically what we are after right now, and you might be wondering how difficult it is to install TensorFlow. Well, let me tell you, it is very simple to install the latest version of TensorFlow, which is TensorFlow 2. Now, ladies and gentlemen, it so happens that you might be using resources online to actually study and work on TensorFlow. But if you're looking at some older content that is present, they would be using TensorFlow 1.x. Now, when you're thinking about 1.x, it becomes super important that there are certain changes in 1.x, and there is a huge change between 1 and 2, right? There are many things that features that were working in 1 which will not work in TensorFlow 2. So it becomes important that while learning, while using, and while understanding, you have the latest one in hand, right? Because when you want to take this to a next level, when you want to go from just learning for your sake, learning for a job, when you want to actually attend interviews and even understand and start using it practically, it becomes fantastic for you to know that, hey, having the latest version in your basket is going to attract a lot of employers as well, right? So quickly, to understand if TensorFlow 2 works for you or not, this is the criteria, guys. You're going to require Python's version either 3.6, 3.7, 3.8 or 3.8 or anything in between there. You're going to require an operating system which can either be Linux or Windows, of course. With Windows, you're going to have to have Windows 7 or 10. I think 10 is super popular, and of course support will be added for 11 as well, I'm sure. You can use this on Mac OS, of course, and Ubuntu as well, right? Now, how do you actually perform the process of installation? installation? Well, it is simple, guys. When you're going to use and install something in Python, you have pip, right? The built-in Python package manager. Now, Python's package manager is super simple to use. It provides a very readable syntax that you guys can use. Now, to make sure that you actually go on to install Python, first thing is you'll have to open up Python, get Python running. Once you have Python running, you have to make sure that you have the latest version of the package manager as well. Now, when you think about the latest version of package manager, this is important because Python works with TensorFlow 2. To get TensorFlow 2 to work and to install in itself, you require the latest one. So the first command is to update the package manager. Once you go on to update the package manager, it is a simple syntax that you can remember forever. Pip space install space TensorFlow. Right, done. And this is basically installing the stable release version, which has been tested, cleared beta testing, and available for use. You can also install these nightly builds, as in these are unstable builds, experimentation builds. Maybe if you want a very particular version that you're after, you can install that as well, right? So if you have the latest pip and Python setup, pip space install space TensorFlow is everything that you're going to require to install TensorFlow. How simple is this, right? One line of code. Let me zoom in a little bit more so that you guys can take a note of this, or I hope you guys are also doing these on the website side by side as me, right? So pip install TensorFlow is literally everything that is required, right? Fantastic, guys. Now that we know a little bit about installing Python and installing TensorFlow, and once we have an understanding about what versions are there, which version works for me, do I need a developer build, do I need a stable build, the next thing you're going to decide is, okay, so where do I use this, right? When you're working with Python, there are multiple places where you can go on to use this. There are many IDEs for Python. First of all, PyCharm is a super fantastic IDE. You can work with multiple IDEs out there. But do you have to run through the entire process of setting up Python, setting up TensorFlow, and working with it? When you think about it, there is a very simple shortcut here, right? TensorFlow is from the team at Google. Of course, it is going to work really, really well with their other Google products. There is one Google product which is super fantastic, which is the Google Colab, right? It's called as the Collaboratory, and in my opinion, the most simple way of how you can use entire Python and TensorFlow is by making use of Google Colab, guys. This, to the people who might have never used Google Colab, is a very simple Jupyter notebook that is hosted on the Google Cloud platform. So all the resources, the CPU, GPU power that is required to work with all these libraries are pulled out from the Google Cloud platform. To a good amount of degree, you can actually have ample amount of resources to run all of your demos, and it's free to use, right? So the most simplest way, without you having to spend a couple of hours installing Python, understanding how everything works, messing around with the environment variables, remove all the complexity out there. The quickest way to get started is just go to Google, type in Google Colab, and you will have a beautiful Jupyter notebook to work with. Now I'm going to show you what it looks like. I'm going to quickly walk you through it. But once you go on to perform the installation, once you run that pip command wherever it is that you guys are running it on, be it PyCharm, be it any place else, you will be very curious to know, hey, I installed it, but is it working now or not? How do you check if something is working or not? You basically try to verify how you go on to do it, right? There's one simple command that you can do. Just like any other library in Python, just import the TensorFlow package as tf, and you can get about checking, right? Now, as soon as you hit it, if there is an error, it means TensorFlow is not installed. But as soon as you run this, eventually you'll not get any printed output on the screen. But at the end of the day, you can, if it runs successfully, it means TensorFlow is installed successfully, right? Now, let me quickly open up my browser here. As I told you, this is the Google Collaboratory that we are discussing here, right? Now, as I told you, to install and verify if it is working or not, it's a very simple piece of code that you guys have to run. It is basically import TensorFlow as tf. Now, as soon as I connect to my runtime, this is just like another Jupyter notebook out there, right, guys? So if I run this, if I don't have any errors, I must have TensorFlow installed. Now, the beauty of this here is I am not using pip. I am not upgrading my pip. I don't have to do any of these things here because of the fact that this is a Google's product working on a Google product. So of course it is already installed. Now, as soon as I hit run, it is supposed to just run and be blank. This means that TensorFlow is correctly installed and TensorFlow is working, right? So this is the process for Google Colab, but for any other IDE out there, all you have to do is install it, run this command, verify if it's running. If it's running, you are good to go, right? Super. Now that we know how to go about installing TensorFlow, how we can go about working with it, we have to see where TensorFlow is used, and we have to see how you guys can go on to use this as well. To do that, you're going to have to take an introduction to understand what neural networks are. Alright guys, let's get started now. When we're thinking about using TensorFlow, as I told you, it is extremely popular for deep learning and it is super popular for working with neural networks. But it also works in production grade machine learning as well. So I thought it's something you should know about. Now, coming to the topic itself, when we talk about neural networks, what are these neural networks and why do we require them? Well, the first most important thing you have to understand something about a neural network is basically us trying to get to artificial intelligence. Us trying to achieve artificial intelligence is through these concepts called as neural networks. These networks are nothing but things that are trying to emulate how a human brain works. Now, I know you guys would know this at this moment of time. You are the most intelligent being, at least that's on paper right now, right? Your computers are faster at, they do things at a lightning pace. I understand they can do certain tasks millions and trillions of times faster than what a human being can do, but you have to also understand that your computer doesn't understand anything apart from zeros and ones, right? At its most fundamental, at its most foundational level, your computer understands only two things: 0, 1. That is it. Now, to get this to be as intelligent as us, to get this to be as intelligent as human being, is the same artificial intelligence problem that we are trying to track. A neural network basically is, again, as I just told you, trying to map how the human brain works and eventually use very similar logics powered by the concepts of mathematics to get us to that point, right? Now, in your brain, there's something called a neuron. In fact, there's almost like a ton of, when I say a ton, it's basically an uncountable number. I don't have the exact biological number, but we have a lot of neurons that eventually have connections and pathways. That's the reason we have something called a conscience, something called understanding, something where we can devise the logic, right? Having this conscious, ability to do things, right, is what steps humans apart from animals out there, right? Animals are instinctive, but humans can think beyond the instinctive things. Now, all these happens because of these neural pathways in our brain, and we are trying to get our computers to do the same thing. That is a quick introduction, right? But when you take a look at a neural network, how are we having, do we require millions and billions of neurons here as well to get our computers to work? The answer to it is no, because let me tell you this: whenever you have multiple neurons, again, some of them will be in the input layer. There's something called as the hidden layers, wherein these neurons actually learn how to go about understanding things in those hidden layers, and you eventually have an output layer. Look at this. On your right side, you have something called X0, X1, and X2. These become the inputs of the neural network. There's a lot of mathematical crunching and operations that happen, after which you get to a point where you have the output, right? So, to see how these neurons work, in our brain, neurons might be same in the biological level, but the way the electronic signals are triggered are different. So how do we do that on the computer? Well, it's pretty simple. All you have to do is you have to attach a trackable numerical metric to it, right? Now, when you see a trackable numerical metric, we're just adding a concept called as weights and bias values to these neural networks. Once we have certain biases, once we have certain, weights that are attached to this, it becomes very important for you to know that using these, you'll eventually have distinctive neurons which can perform distinctive tasks for us. So if we have millions of neurons coded, and eventually we know how to differentiate one from the other, how do you know when each neuron will fire? How will you know when each neuron will work? Right? That is where we have a concept called as an activation function. With the activation function, the neuron is provided a value through which it says, hey, if you cross a certain threshold, you are firing, you are working. That is how not only can you just track how many number of neurons there are, how many number of distinctive neurons there are, but at the same time, you can check how many of them are firing, how many of them are working, how many of these neurons are contributing to the next couple of steps and layers out there. Isn't this absolutely fascinating and fantastic, right? The way neural networks work is the reason why, for myself as well, the curiosity that led to me understanding artificial intelligence is the reason I am a subject matter expert today in this, right? I am absolutely fascinated by how these work. Now, coming back to the point, I told you one important thing where I said about weights and biases. Well, what are these things called weights that we are trying to attach? Are they physical weights, or do we have physical weights in our brain for neurons? Well, no. Weights are mathematical concepts that gets multiplied with the input to eventually give it some meaning and make it distinctive. These weights are not just to add meaning to your particular neuron. You have to understand that these weights are used to tune the same neuron as well, right? Because how a network learns is that there'll be multiple interconnections and multiple layers through which your neuron fires if it thinks of the right condition. If it finds the right environment to run, it runs, and it understands and it maps certain things there. But if it just works once and it's done, it doesn't make sense. You'll have to find ways of how making this work better. This is not a switch, right? It's not like a turn it off, turn it on switch. Yes, it is a turn it off and turn it on switch to make the neuron fire. But is artificial intelligence something as easy as off and on? No. So to get to the point where you tweak efficiency, you eventually find ways to go back into the network and make the network itself better. This is where the concept of back propagation comes into the picture. Every time your network learns something, it might have learned it well, or it might have learned it in a really bad manner. So what you do is simple. You just test if it has learned things correctly. If it has learned things correctly, good. If it has not, however, you will go back, retrain it with new values, new weights, new biases to make it more closer to the output that you are expecting. And eventually you can adjust them, retrain them, and verify if your adjustment worked in your favor or against it, right? To do this, there are weights. Now let me quickly go back to the previous slide here, and you can see these, right? X0, X1, and X2 are the actual nodes, the input that we are taking a look at. And these W0, W1, and W2 are the weights associated with those neurons or nodes. Once I told you that these are multiplied with the input, you can see this, right? X0 multiplied with W0. This becomes the value for this neuron. Again, this becomes the value for this one. This becomes the value for this one. Eventually tweaking it and getting it to move around the network to see what should work when is what biases take care of, right? So I hope with this, you have a basic understanding of how things might work when you're taking a look at neural networks. However, does this answer the question saying, do we just multiply one value and we are done understanding how artificial intelligence is achieved? Absolutely not, right? There are certain things, even as a beginner, that you guys are recommended to know, especially in the lines of how certain mathematical concepts work well in neural network, right? To answer that question, this is a super important section where we'll take a couple of examples to see if we can know what we are trying to do here, right? First of all, let's take a very simple network. In fact, let's take two input variables for this particular network that we're talking about, and those are numeric values, as I mentioned. Correct? Look at this. We have x1 to be one variable with a value 0.6. We have another variable x2 with a value of 1. Now, of course, you have input variables that require weights for it to be associated as a neuron. Of course, we have weight 1, which is 0.5, which goes with x1. Weight 2 is 0.8, which goes with x2, right? x1 w1, x2 w2. Now, what is the important thing here you have to understand is something called threshold value. We'll discuss what the threshold value is, right? Now, how the neuron moves, how the data moves from one function to the other to see if that neuron should fire or not, is what the threshold value will tell you, right? Remember what I told you, x1 w1 plus x2 w2, that is giving us the transfer function. Now, I have all these values on your right and the calculations on your left. So once we calculate x1 w1 plus x2 w2, we are getting a value of 1.1. But you remember that the threshold said 1. Now, what are we doing with threshold? Why do we require it, and how does it associated with the value that we got? First of all, let's check the output that we got. The output that we got was 1.1, correct? What was the threshold value? It is 1. Now, when we compare the output value and the threshold value, just do output minus threshold. What is this value that you're getting? 1.1 minus 1 gives you what? 0.1, right? Now, In this particular case, our output is basically greater than the threshold that we have at hand, right? Our output was 1.1, our threshold was 1. Now, if our output crosses the threshold in a way, the neuron is activated, and the transfer function, the value associated with the transfer function eventually is what you see on your screen, which is 0.1, right? So we didn't have to talk about this, but I had to give you this extra clarity so that you know when a neuron is activated, when a neuron is not activated as well, right? So if your output value after multiplication is greater than a threshold that is set, it means that neuron is activated. It means the neuron will fire and it has a contribution to the output, right? This is a very simple thing, yet if you do not understand how these concepts of weight works, how the threshold works, how the output works, as I just told you, there's a very good chance when you're applying for a role or eventually you're trying to learn very complex applications and to solve data sets, you might not know why that particular neuron is being activated in any type of model that you might have. A popular one is sequential model, right? So to understand how it works, we require this mathematical knowledge, and with this, again, I hope that all of you all have complete clarity on how this thing works, right? Fantastic. Now coming on to the next section. Alright guys, now it's the time we actually get started to work with TensorFlow, right? We understood the theory to a good extent, even with respect to neural networks, even understanding what the mathematical aspects of weights are, biases are, and how they have an insight to say and what role they have to play in a neural network, right? Now, once we took a look at all of that, you must be very curious at this moment of time to actually understand what a tensor looks like, how does it work, how can we programmatically write a tensor and eventually get this tensor to perform operations for us, right? I am sure you all are curious on that note. Well, to answer all of these questions, we have to start out by telling you one thing, guys, here. Now, whenever you're practicing anything from this point on in this tutorial, just make sure that you're practically working alongside me as well. Because be it TensorFlow, be it any other deep learning library, this happens a lot, and this happens even with experienced professionals. When you look at the piece of code, it'll be like, oh, okay, so it's very simple. I can do it too. And probably you can. But when you're actually, when you close the piece of code and when you try to implement it yourself, that is when things will slightly become difficult. Now, this is a common pattern with beginners, intermediate users, and sometimes if it's a very complex program to implement, even with advanced users, right? So to make sure that you are up to speed with all of these, make sure you get your theory completely straight and set and eventually get started with practicals, because with the practical aspect of things, when you walk through and understand the code and when you do it multiple times, that is how you become proficient in this concept, right? Fantastic. Now you should be asking a question at this moment of time, and this question is, what is the process of writing TensorFlow code? We've discussed about the theoretical aspect of things, but when you have to build a tensor, when you have to make your computer understand what a tensor is, and eventually you have to understand what a tensor is to make sure you can implement multiple of these in a neural network, right? So there are actually two important steps that we're going to take a look at whenever you try to say, hey, I want to write TensorFlow code. Now, we looked at the introduction, we looked at installing it. At this moment of time, all of you all should have it set up for these two steps. The first step is for us to understand that having these tensors eventually means that a computational graph, the flow of data, as I explained previously, will actually be the reason of how data moves around, right? Data entities get converted into computational graphs, and these computation graphs eventually get to be the solution and get to be how a channel, a pathway for the data to flow around, right? So to get to the point where we will have a computational graph in hand, it is important for you to understand that to do this, we require two steps. One is to actually create these computational graphs for us from tensors. The second thing is to actually run these graphs to make sure that you can work with any sort of graph related operations, right? Now, once your data goes into the form of a computational graph, moving data around becomes really simple, becomes trackable, and eventually you will understand in a very complex neural network, if there is one or two nodes which you think you can tweak and tune and do it, it is possible to do so. Why? Because of the mathematics that is behind it. You have a trackable metric there, and eventually to get to that point itself, your data was converted into computational graph, right? Okay, fantastic. Now that we know that we have to create a computational graph from a tensor and we have to run these to ensure we have an operation, I think it's high time we take a look at our first tensor operations. Right now we are clear with the usage and understanding of the basics of tensors, but here is a piece of code on your screen which says x equal to tf dot constant of 10, y equal to tf dot constant of 15, z equal to x plus y. Now ladies and gentlemen, there is one important thing that you have to assess and analyze here. Doesn't this look very much like a mathematical operation? We have a tensor which has a value 10. We have another constant value which is 15. So what do you think happens when we add this? Is it 25? Or do we get something else as an output, right? We have never performed a tensor operation, so it is high time we check this out practically, right? Let me go back to Google Colab now and we can check it out there. Now, let me just open up this tensor demo that we have, right? Let me zoom in so that all of you can see, connect to my runtime, and I can zoom in a little more, right? Superb, guys. Now, let me actually go on to quickly clear the output as well so that you guys, stay a little bit curious. Okay, fantastic. Now that we can see this, ladies and gentlemen, for the first step is to always import TensorFlow, right? You can write this piece of code alongside me. We have x, which is a variable. This is basically a constant tensor, right? We can have constant tensor, placeholder tensor, variable tensors, sparse tensors, and a lot more. In this case, we're using constant. What does it mean? Well, I'm trying to say that, hey, this tensor has a constant value of 10.0 and it will absolutely not change. So regardless of where it is positioned in a network, the value of the constant is always going to remain same. So whenever you use x and y, these are tensors with respective 10 and 15 values. So as soon as I run this, you will see the actual mathematical operation that happens, right? 10 plus 15 is what? 15. So 10 plus 15 is what? 25, right? But look at the output that you get. This is not just as x equal to 10, y equal to 15, add it up. No, this is two tensor operations that we are trying to do here. And the output will tell you that, hey, this is a tensor and it has the value 25 and the data that you have sent is a float value. Why is it a float value? Because we have 10.0, 15.0. Of course, it is the same as 10 and 15. Now, this is very important for all of you all to understand and to know that, hey, we can perform any operation. Now, there might be some of you curious out there saying, hey, why did you add? Why can't you multiply? Well, sure you can. All these operations are possible on tensor. So make sure that you try a couple out, try multiplication, try division, try floor division, of course. So I want you guys to actually get your hands a little dirty out here and make sure that you're actually trying this out practically. And alongside z equal to x plus y, try these other operations that I just mentioned. Right? Fantastic. Now that we understood, and I quickly told you about the three types of tensors that we have, right? Constants, variables, and placeholders. Now, when we're talking about constants, variables, and placeholders, one important thing you have to understand here, ladies and gentlemen, is that the answer to what they mean lies in what the name itself is, right? These are the three types of tensors. There's a fourth one, it's called as a sparse tensor, but eventually it gets a lot complex. So to make sure you guys have a simplified, structured start to your TensorFlow journey, these three are going to be the most popular ones that you will be using, right? So let's clear things up between constant, variable, and placeholder. Now, with respect to constant, what do you think when something says it's a constant? We just checked it out, right? If I store x equal to 10, let's assume that it's a tensor. It means it's going to remain 10 forever, right? Until I want to change it, until I've changed it, it's going to be the same. Pi is 3.1418, etc. And you can't change that. It's going to be the same thing everywhere, right? That's a good example of a constant. We use multiple constants in the world of mathematics, in the world of physics especially. So if you guys know any other constants, head to the comment section and put them down as well, right? Now, constants are fun. We understood what they mean, but one thing you have to understand about these constants is the fact that they get initialized as soon as they are called. Now, there are two ways of how you can work with tensors, right? One is to make sure that you have initialized them, you're calling them. Think of it like a function, right? If you have a function, you'll have the body of the function. You'll have to eventually call the function to make use of it, right? But here you don't have to do it as a separate process. X equal to tf dot constant, exactly what you saw there. That is all that you have to do. Well, if that is the case, and why is it actually initializing as soon as they are being called? As soon as that line runs, constants are initialized right then and there and not before, right? Well, this is the case because we want slight flexibility in terms of how we can work with variables. Now, variables, it's a little bit different, right? Whenever you're trying to define any sort of variable, what are you trying to do? You're trying to provide an initial value that it can use, right? Now, x equal to tf dot constant is something that we understood as a constant, putting it into a variable for Python. Here we're talking about having a variable tensor as well. Now, what is more important about variables you have to understand is that constants are fantastic. Constants can be used everywhere. They will remain at the same value. But if you have a very complex neural network and your values are the same, well, it doesn't work in any of our favors, right? We'll always have new weights. There's a good chance we'll have new bias values. So there are so many things which are new, and eventually you can't say, hey, I want like a new variable, or I'm going to be using like 1,000 constants, right? It doesn't make sense. That is the reason we have variables. Now, variables is basically giving you one important flexibility. It is to basically telling you, hey, you can vary any input that you have, right? For example, you will have the same couple of inputs and eventually they'll be the same as constants. But what if you have same inputs? With the help of TensorFlow, if you can vary it around, store it, change it around, there is your flexibility, right? Same inputs, different output, and this is super important, not just in deep learning, but in many places where you're using AI-based applications, and of course they are derived from neural networks itself, right? So understanding that you can have extremely similar or exactly same input, and you can have a playground wherein you can work with these, change these values as and when required, right? The way neural network works, you know this, right? All the data moves in the forward direction once, and to tune and tweak the network and to make sure we bring down the losses, we have something called as backpropagation, where we keep going back into the network in an iterative process to make sure that we are tuning and tweaking these numeric values which are stored where? In the variable tensors, right? So I hope you have a complete picture on that. Now, whenever you're training something is where your values will usually change, but whenever you're trying to loop back into it, in backpropagation, it changes as well. So hey, there is another advantage of making use of variables. Now, one thing you really have to know is that whenever you actually go on to define a particular variable, right? Now, if it is a tensor variable, you have to be very careful to make sure that you actually provide the initial value of the variable that you're trying to use. Now, if you just have a variable tensor, and if it's blank and if it's empty, it gets very confusing for a neural network and it is syntactically incorrect, right? If you have a variable, just put a dummy value, put a start value. The name itself says variable. You can vary it later down the line, but it is super important that you understand that there has to be an initial value while working with these variable tensors, right? So now we understand what are constant tensors. We understand what are variable tensors, but what about placeholder tensors? What are these? Right? Now, one important thing you really have to check out here is the name itself again. When something says placeholder, it means that it's being just put there temporarily, or it is serving as a substitute or something like that in the real world, right? Here also, it has a similar meaning. Now, whenever we're thinking about a placeholder, all we are trying to do is basically saying, hey, these are certain entities which are not yet initialized. They do not have any sort of data, but we want them to be there because even if you don't use them right now, there will be a dynamic value that will be stored in them later down the line, which is probably required for the graphs to execute. When that is the case, you just want the structure to be there, but no initialization, no data, and you know that later, instead of creating it and being confused and not understanding what variable does what, you just do it at the start, do it in a structured way. So when you're actually working on the logic, when you're actually working on building the network, you don't have to to break a sweat on any of these, right? So this will just serve as a structure eventually upon which you'll store values into it, you'll initialize it whenever it is needed. So guys, with this, I hope you're clear with constants, variables, and placeholder tensors as well. Because once you are done with this, it is high time we take a look at a couple of hands-on sessions we have planned for you, right? Now, there are going to be two important demos that we're going to take a look at. And guys, we're going to be working completely with Python, just to reiterate for you guys. Now, you are going to require the understanding of Python syntax in itself as a prerequisite before watching this section. So make sure you're up to speed with Python. Well, even if you do not know Python syntax completely or the TensorFlow syntax completely, I'll try to break things down in the most simple way possible so that all of you all watching, regardless of being beginners, intermediate users, you guys will understand, right? Superb. Now we'll discuss two important use cases, guys. One is digit classification using a super popular dataset called as the MNIST, or we also call it as MNIST dataset, right? Done. Once we're done with that, we'll also understand and in fact take a quite a deep look at understanding how convolutional neural networks work by performing some image classification, right? In fact, the first one is also a part of image classification, but once we take a look at it, you will understand the kind of images that we are trying to sort out there. Right, so let's get to the first out of the second demo that we have, digit classification using the MNIST dataset. Now, this is considered to be a demo which you really have to understand thoroughly if you're starting to build your journey in TensorFlow, right? Because once you're clear with really basic and simple datasets and understanding how you can work with these, later when you have an opportunity to work on really large dataset, it becomes super simple, right? Now, the image that you see on your screen, for all the people who might have not been who have not used MNIST dataset, it is basically handwritten digits. Now, it's common sense to know that not everyone has the same handwriting, right? Now, I might write 0, 1, 2, 3 in a very, very different way that someone else might do, right? Probably you just think about a couple of people, just find 5 people in your house, 3 people in your house, ask them to write a couple of digits and just compare if it's the exact same thing. The digits will be the same, the way they might have written the strokes, right? In fact, look at your screen right now. All of these are numbers and you will see, of course, with 0 to 9, we can have infinite numbers that we want, right? You can have 10, 100, all the way to million, billion, trillion, and whatever those numbers are. For all those numbers, you just require 0, 1, 2, 3 up to 9, correct? Now you'll see, if you observe very closely, that all these zeros look very, very different to each other. All these ones look different, twos are different, even though we as human beings look at it and we're like, oh, okay, this is a 2. Even look at this doesn't look like a lot like 2. So if we had context, we would know this is a 2. If we did not, well, even as human beings, it becomes difficult. This is exactly the point here. If you have any handwritten document that you want your computer to analyze, and this is extremely popular in the world of, I think in the legal world, where you have a lot of actual hard copy documentation papers which need scanning, and computers need to sit and analyze thousands, if not millions and millions of these sheets and letters that are out there on those sheets, right? So it's super popular there, and your computer will be super confused if you give this value as a 6 and eventually ask it and train it with this and showcase what this is. It will say, hey, I have a low probability of thinking it might be a 6, right? If it gives you a 30% probability that it is a 6, well, you will be confused. Either your model is not working fine or whatever it is seeing is not a 6. Here, it is not both the cases, right? It is trained on something else. You're asking it to understand something else. Again, roll back to the same example where I told you your computer will understand only zeros and ones, right? Now, that is where you have to be very careful. What we are going to do is we're going to take an entire data set of each of these handwritten digits. We're going to take all these zeros, all these ones, twos, threes, up to nines, and we have separate files for them. And eventually, we will train a deep learning model based upon this. Now, once you go on to train a model, later you can perform an image classification operation, or you can perform an operation saying, hey, what percentage or what probability did you get whenever your neural network model figured the digits out correctly or incorrectly. You can train it, test it, and verify if it has learned something or not, right? And as I just told you, MNIST dataset is usually the go-to dataset whenever anyone begins their journey in the field of deep learning. Now, I'm not saying that you have to learn this to go ahead. Absolutely not. There's thousands and thousands of other use cases you can use to learn. But this is very popular because it just gives you a very strong foundation to understand everything that goes ahead, right? Fantastic, guys. Now, let's quickly go back to TensorFlow that I have opened on Google Colab here and get started to know what it is that we are doing. Let me zoom out a little bit so that we have better readability, right, guys? So we know what the MNIST dataset looks like. It's a couple of images where each image is a handwritten digit, a single digit, right? So we'll have to use a couple of steps to actually attack this problem and solve it in a structured manner. The first thing that we're going to do is, of course, import TensorFlow, right? Now, if you do not do this, wherever you see TF here, right? Basically TF.keras, TF. Model layers, TF.flat and dense. If you do not do this, you'll have to use TensorFlow dot as everywhere. So basically, we're giving it an abbreviation. We're telling Python, hey, import it as this. So wherever I have to use the word TensorFlow, I'll just replace it with TF and it'll work fine. Very simple, basic piece of code, right? Now, ladies and gentlemen, one thing you really have to understand about TensorFlow and MNIST dataset is that the dataset comes built in whenever you install TensorFlow, right? Look, even the people at Google definitely want you to learn MNIST. It's available on their official documentation, and this is the same data that you would be seeing there as well. So MNIST equal to tf.keras.datasets.mnist. So all I'm trying to tell the particular compiler here, sorry, the interpreter here is that, hey, just pull out this dataset and bring it and call it MNIST. Right? Now, the next part of the code where we're trying to say is we are loading the data and we are splitting the data into test and training this. In this case, we don't have to manually make a split because the data that we have at hand is already split into testing and split into training, right? Now, as soon as I go on to hit play, so it will start downloading all of the MNIST dataset from the internet. Probably this is going to take a couple of minutes, 1 or 2 minutes, and eventually you will have it all downloaded and ready to get started with, right? So let's just give this a minute and let's tune back in as soon as it's done. And guys, that just took a minute of time and it is done. We have our values loaded and eventually our data set is ready to function. Now, what's the next step? The next step is you guys defining a structure to your neural network, right? We're using a neural network which basically has a couple of input layers, it has a couple of hidden layers and an output layer, right? Now, it can have one input layer, multiple hidden layers, and one output layer as well. So we have to give our program a structure saying, hey, use these many layers here and there. This is where we define the layers out here, right? Now you can see something called as sequential model here. The first question you guys are supposed to ask is, hey, so what is this sequential model? Sequential model is exactly what I just said. It's a structure wherein one input node can connect to any other nodes, and similarly this goes on as a one-dimensional chain all the way to the end of your output layer, right from the input layer, right? Having multiple layers in the middle is also possible. Now there's something called as activation function. Now if you do not know what activation means, just make sure you're revisiting the theoretical concept, because if you want to use a methodology of understanding which neuron should fire at what point of time, you're gonna have to give it an activation function, right? Now more on this in the next demo that we're about to take a look at, because I'll be explaining how something like ReLU works there, so there you will have complete picture on this, right? But for now, understand that we have an activation function which is eventually squishing all of our values to a customized range to make sure that we can work with it. Now, why is this required? I will tell you when we're discussing the convolutional neural network demo, because there I can show it to you with an example saying this is why. Okay. So at this moment of time, running this piece of code creates a structure. We are telling our neural network model that, hey, we want to be using the sequential model out here. We have a couple of input layers. We have a couple of output layers as well. And make sure that you're using the activation function. Which is the activation function? It is ReLU, or rectified linear unit. That is what ReLU stands for. Right? Fantastic. Now, whenever you're taking a look at the models, you have to understand what it is that your model is trying to do, right? So we'll just take a look at what the output is in terms of its predictions and in terms of what we can expect the model to do. As you can see, you will find an array here, right? So this array is basically telling us we have a lot of vectors on our hand. Now, remember the concept of scalars, vectors, and tensors that we studied previously here, right? So this is something what the prediction would look like based upon our training data set. Now, what we need to do is directly using these vectors will not be possible for us. What we want to have is a probability of each of these classes instead of having individual vectors at hand. Now, why is that done? That is done to make sure you have this kind of a continual network that is built in, right? It's not like one node will connect to only one other node in the network. No, just like how we have in our brain, one network can definitely connect to a lot more of these neurons as well. So to make sure we have a way to predict, to say which worked well, what worked, what not, which did not work really well, basically, right? So for that, we have something called as prediction, and in this particular case, we're using something called as softmax. Now, there are multiple ways of how you can perform prediction, and again, the most popular way for you guys to get started with is softmax. Here is one important thing that you have to understand, ladies and gentlemen. These are vectors with negative numbers in most of these cases, but if you take a look at after using our softmax, all these values are now positive, and of course they won't be the same because we're running predictions on them now. So it is fine. We understood from the first step, we loaded the data set, we understood what the model will look like physically, we understood what the output looks like in terms of vectors. We also understood we require the probability of classes rather than vectors. The next step is to make sure that you have a way to understand, you have a metric to help you tune the network out, iron it out, and make sure it is fine, right? For that case, we have something called as the loss function. The loss function basically is telling you how much of a mistake your neural network is making when it's classifying or whenever it's doing any task, right? To make sure that your neural network works really well, to make sure you score really well on your examinations in college, do you want your losses, do you want your errors to be at its maximum or at its minimum? Simple, it has to be at its minimum. Similarly here, what we try to do is we try to bring this loss value to its most minimal possible. That way we understand that, hey, the loss of the model not able to understand what's going on is very, very less, and the accuracy will just go up. As the loss goes down, accuracy goes up. As the loss goes up, accuracy goes down. So it's an inverse proportional. Make sure you guys remember that. Now, as soon as I run these two steps, it is basically trying to find out the loss for each of these examples, and the current loss function that we are running is giving us a value of 2.4. Okay, this is what we'll have to get started with. This is not going to be the final loss value that we're going to have, because what's the goal here? The goal here is to make sure we bring these losses down to a complete minimum so that we have the highest amount of accuracy. Fantastic. Now let's just click on model compilation here, and as soon as I compile, you'll see we have another entity here called as an optimizer, and in this case we're using something called as an Adams optimizer. Again, when we discuss the convolutional neural network part, you will understand why all of this is required with an example on the screen as well. But for now, understand that there's multiple ways of how you can optimize the loss function. And why are we doing that? Again, to bring the value down. So as soon as I run this, we would have compiled the model. The next step is where all the magic happens. This is the step where we call model fitting. When we say model fitting, all we are trying to do is, give the training data to the actual neural network and get the neural network to actually, figure out what is going on. Train, this is the process where it actually learns. This is the process where it actually trains. Now, you must understand that this process of training is not it's not a one-time thing. You don't train once and you say, no, right? You keep training, you keep doing the same thing over and over again to get better. Similarly, if you're going for a run, if you're going to the gym, you would understand this concept. No matter what you do, if you keep doing it a couple of times, you'll get good at it, right? This is what the model is also trying to do. You see that we are trying to mimic human behavior here, but here we have a trackable metric to say, hey, you have to learn it these many times, and I want to track what's going on when you're learning it that many times, right? Now you'll see a new term here which basically says epochs. Epochs, for all the people who do not know, is how many times I want this model to train. In this particular case, I've said, hey, please train the model 5 times. So as soon as I run this, it's going to take a couple of seconds here, and you will see that the entire model is training at each of these epochs. And let all the 5 complete, I'll let you actually track the accuracy and losses there, and you will have complete understanding of what is going on here, right? Now 5 epochs are done, as in the model has trained and ran through the entire MNIST data set 5 times now, and when it did it the first time, the loss value was 0.29, but when it did it the second time, it was 0.14, 0.1, 0.08, 0.07. Ladies and gentlemen, do you understand at this moment of time that the loss is continuously going down with more and more epochs, and the accuracy as well is going up and up, even though the number is not that great of a difference. For example, 0.9728 and 9766, they don't differ a lot, but it means that more your epochs, more your accuracy. Is this always the case? If so, I'll just run this 10 million times and eventually have 100% accuracy. Would that work? This is where a concept of overfitting and underfitting comes into the picture, especially overfitting. When you train your model, when you ask your model to hunt so much into your data that it tries to find noise, it eventually finds more noise than useful information. This is the point where we call overfitting. What will happen? Let's just say you're digging for treasure on a beach. You know where the treasure is, right? Now you're digging, and you're digging. Eventually, if you don't dig enough to get to the treasure, where treasure is at 10 feet, you've just dug at 5 feet and you give up. Do you get the treasure? No. That is underfitting. When you go on to start digging and you dig so much that you've crossed the part of the, you've crossed the treasure, and you're eventually going further deep, and you don't have any clarity. You might just find a couple of coins here and there, but you will not find the entire treasure box. Similarly here, even though I might run it 25 times, there is no guarantee that accuracy will go up and the loss will go down. In fact, let us actually give it a shot as we speak. Since it's a very short demo, I can actually run this for 20 epochs to actually check if there is any sort of fitting that might happen, right? Now, again, now it would have run again. You'll see that the loss is also lower to begin with. The accuracy is already going up and up, 0.06, 0.057, 0.053, 0.48, and we'll just have to wait this out, right? 0.985, 0.986, right? So look at this. There will be a point of time where your gain will be very, very minute, and this is a very small problem, ladies and gentlemen. Every epoch is taking like 4 or 3 seconds at max. When this is the case, you can run it for any number of iterations you want. If you want 10,000 iterations, just put it and walk away. It'll finish and it'll be done in a couple of hours. But what if each of these epochs takes a couple of minutes or a couple of hours, right? This is the reason you would have heard the common statement where people say, hey, you require a very powerful system to run with TensorFlow. Sometimes you require a very powerful graphical processing unit to work with as well, right? That's the reason why we don't want to overwhelm the computer that we have at hand. Now, look at this. Here is exactly the situation that I told you, right? One situation is that these two accuracy values are exactly the same thing, right? In fact, the loss just went up here and the accuracy remained the same. Here is another fantastic case where your accuracy was 99.17%, but later it came down to 99.11% because here it has started hunting more into the data where it does not understand what exactly is going on. In this epoch, it is getting confused. But of course, since it's a very simple data set for a super powerful library like TensorFlow, this is literally nothing. It's no match for it in any regards. So you will see that, hey, even even though we thought that one or two places it might get affected, of course it did. The loss initially that we started and the accuracy that we started initially is gone. The loss has gone comparably down, and the accuracy has gone up from 97% all the way to 99.24%. Now, whenever you're working on this, it is very easy to get carried away. You can say, hey Anirudh, it looked very nice that we did it for 20. Can you do it for 35 also? Ladies and gentlemen, you can actually work on these codes side by side, and I want you guys to give it a shot. See what happens when you run 50 epochs. See what happens when you reach 100 epochs, right? It'll take a couple of minutes. Every single epoch is 3 or 4 seconds at max, right? So I hope you guys understood one basic concept here is that no matter you can train something for days and months and on, it doesn't mean that it will get accurate. In this case, yes, there was one or two gains that we made, which is good enough, but this is very common to happen. Your loss will start going up again and your accuracy will start going down. Why is it? The technical term, it's called as overfitting, and your model just runs through noise rather than useful data, right? So once we have trained our model, once we are done with this step, it's almost like you guys have your textbooks for your examinations if you guys are in college or school. So you can take a look at it, you'll be reading it, and eventually you'll close all of it, keep it outside, go write an examination. Now with model evaluation, we're basically giving an examination to our model saying, hey, you have never seen testing data before. It has seen what? Training data before, and testing data is brand new to it, just like how you will find questions on your examination. So as soon as I give it this data, it is basically trying to find out if it can understand something at its accuracy. Look at this. This is absolutely fantastic, right? We have a loss of somewhere around 0.0950, and eventually our model is giving us a 97.98% accuracy. Now you can tune it to multiple epochs, you can evaluate to multiple levels of accuracy that you require, but it's a very simple data set. And if it's somewhere around 98, right, this is a percentage, ladies and gentlemen. 0.97 basically means 97.98% is the accuracy. What you can read about it is that if you have the MNIST data set, if you give it 100 digits, out of which it has the complete accuracy to give you the output for 98 of these correctly. So if you give it a 1, if you give it a 2, 3, 4, 5, if you give it all these digits like this, if you give 100 digits, 98 of them it will predict perfectly. 2 of it might get confused, right? I mean, we saw the digits. The 6 doesn't look like a 6. The 2 doesn't look like a 2 at all. If we as human beings can get confused, imagine the state of your computer. That is the reason why MNIST is a fantastic challenge. Even though it's a very simple one, it will help you understand how this entire process flow works, right? So this is not the only demo that we have planned. The next thing that we're going to be taking a look at is image classification by making use of what? By making use of convolutional neural networks. Now there is a very good chance, ladies and gentlemen, that you might say, hey Anirudh, this is fantastic. MNIST was very simple to understand, but I have never worked with convolutional neural networks. I might not know what it is. I have never used it. I don't know how it works. Well, what are we doing right now? Very good question. To make sure that you guys have complete clarity, I'm going to be discussing what convolutional neural networks are, or CNN as I'm going to refer it from now on, is what it is, and eventually I'll tell you the steps of the logic, right? How does it even work is exactly what we're going to take a look at theoretically, and as soon as we go on to jump into the demo, you will have a complete understanding of why things work the way they do. Right now, we spoke a little bit about why we have to use activation functions. What is the purpose of it, right? We realize that we might be doing it to make sure we are squishing a value to a range, but why do we need to do it? Why do we have to only use ReLU? Why can't we use something else? Why do we have to use softmax? All the answers to those questions are in this particular demo, guys. So without further ado, let's get started. Alright guys, so as I told you, we need to understand what a convolutional neural network is, right? Now there are multiple types of neural networks. There's something called as a perceptron. There's multiple types of perceptron. So you can find all of these types of neural networks that are out there, which are possible, all the combinations on the data science full course that I have here on Great Learning, right? So make sure you check out the 10th module there. The 9th and 10th module will completely walk you through the concepts of deep learning. learning and TensorFlow. It will also walk you through not just using TensorFlow, but also telling you about these types of neural networks that are out there. Now, convolutional neural networks are super popular for one application: image classification. Anytime you're working with any sort of dynamic data like images, videos, music, these neural networks are this type of neural network, convolutional neural network, is super popular to work with. Why? You're gonna understand when I walk you through the demo, right? So guys, there are multiple layers, there's multiple processes which will help a neural network work, especially a convolutional neural network. To make sure that we have covered all the bases, let us try to understand what each of these layers does to eventually get us to the output. What your input is going to be in this particular demo is a lot of pictures of cats, a lot of pictures of dogs. What we will try to do is try to send all these pictures of cats and dogs to a very very powerful neural network, and we're gonna ask if it can predict if it sees a cat or if it sees a dog. Right now, when we look at a cat and a dog, we understand it because we have grown up with it. Probably we see them a lot, and we are not surprised when we see a cat or a dog. But your computer sure is surprised because it doesn't know what a cat looks like, it doesn't know what a dog looks like. And even if you train it to see 10 cats and dogs, there's a very good chance if you just click another pose, right, maybe from the back end or maybe from the side or maybe from the top or the bottom, it will get confused, right? To a very good extent, cats also have tails, they have 4 legs, they have a mouth, they have a face. So does a dog. So it has to understand the features to a good extent to classify it as a cat or to classify something as a dog. Right now, to make sure we get to that point, that is the reason why we have chosen this demo for you guys. To get there are 4 layers of which how a convolutional neural network works, and here is a quick brush through of how these layers work. The first layer is basically you giving images. Right now, when you are sending images, what are they? Pictures of cats and dogs. Now, the pictures of cats and dogs, the computer understands it as numbers. What kind of a numbers? It is basically an array of values which will talk about luminescence, which will talk about red, green and blue values as well. And I'm going to show it to you when we go to the next slide. So the first step is to take images, convert it into some sort of an array. Okay, what later after that? The next layer that we're going to take a look at is basically us trying to bring that there will be certain negative numbers. You will understand why we cannot have negative numbers, and we'll eventually bring all those to 0. And once we bring all those to 0, there's a very good chance your data will keep growing and growing and growing because we converted one image to a huge array of data. So based upon that, we will have to make sure that eventually your model does not get out of hand. Your image, your input data, your number, your trackable metric does not go out of hand. That is where we pull it and we actually reduce the size of it to make sure it doesn't blow out of proportions. And after that, we will have a model which trains itself and understands what goes on throughout the entire network. So we'll just bring stuff together and eventually get it to work. Right now, that is very simple said and done. If I just walk you through the theory right now, there's a very good chance you guys might be confused. So let's actually dive right into each of these layers to understand what's happening. Now, the first layer, the convolutional layer. Right now, this convolutional layer, as I told you, basically is taking any image that you want. You would have clicked 1,000 pictures on your mobile phone. So when you take a picture, send it to a convolutional neural network. In the first layer, it just breaks this image down into multiple pixels that are out there. And each of these pixels, of course, has a value, right? In fact, you have a very nice trackable metric that all of you all know about. It's something called as screen resolution, right? 1920, 1080, full HD, 4K, 8K, all of these things, right? So those are actually the number of physical pixels that actually are present in your screen, which is eventually giving you that kind of a resolution. Here, each of those pixels has to work in a specific way to give us image, right? When we watch, in fact, you're watching this on your screen right now, all of these has to be only blue that I have here. This has to be orange, this has to be green, the background has to be white, text has to be black, here it's gray. So it has to have some of these values for each pixel that tells it what it has to do to contribute to the big picture. To do that, each pixel has a numeric value. We're going to be using this going ahead in the next couple of layers as well. This is where I told you the magic happens. Now look at what you have here. You have pictures of two beautiful dogs, two cute puppies out here, right? Now what this you have to understand here is, just think of it as if these numbers were not there on the screen. You just see two puppies. But what the computer understands it as is these numbers. Now why are they certain numbers which is like single digits? Why are there some numbers which are like super high out there? What are these numbers? How do we read them? Well, we're talking about the light and dark areas in an image, right? See, wherever it is comparatively dark, you have these values to be low. Wherever it is super bright, for example, here where it has its face, which is again white, there is no brighter than white, because to make white you have to bring all the colors together, red, green and blue, right? So once you go on to check this out, all the dark areas have the pixel value to be low in terms of luminosity. All the values where you have a lot of things that are presented on the screen, these values are high, right? Now this image gets converted into an array that looks like this, where it just wants the pixel values that are present for those locations, and it eventually uses this array for everything going ahead. Now just by having this array, we cannot detect if something is present or not. Remember, whenever you're trying to test for something, you have to just you have to get in there, you have to test to see if there is something that you're looking for. And to do that in this particular case, we make use of a concept called as filters. Now what filters do is, basically we run this filter, we take this short 2x2 matrix and we run it across all of these elements out there, which will basically give us the features that we have. For example, if I run a filter or a feature extractor on these couple of rows and columns out there, and if this is the output that I get, you'll realize two things. One, now we have ran a filter to tell us what the image means, so your computer understands what the image is. Secondly, we also have a method to reduce the number of dimensions going ahead, because if you don't work on dimensionality reduction, your model is just going to blow up and up. Now whenever you just see this matrix multiplied with filter, you don't have to be confused saying, hey, how is this even possible to work with this matrix and multiplied with this? It doesn't make sense. This matrix fundamentally cannot be multiplied with this, but how are we doing it? Well, to get to that, you'll have to wait till the next layer. But for now, you have to understand that we have to use ReLU, right? Regularization, rectified linear unit. We use this to actually convert all the negative numbers down to zero. Look at the graph on your right side here. Why we do this, I'll tell you, but just take a look at this. No matter what negative input you give, it is going to remain forever zero. If it is -1, it will be zero. Your output is going to be zero. If it is -10, -100, -million, minus whatever, if it has a minus sign, that value is converted to zero. That is why we require ReLU. But what about the positive values? Look at this. F of y is equal to y. It means whatever positive values you have, it remains untouched. It remains as it is. Only the ones which are negative are the ones we want to mess with. But why do we want to mess with all of these numbers, right? Look at this. For example, there is a -2 here. What does -2 say in the real world, right? See, all I'm trying to say is 0 is black. The higher the number, the more white, the more color, the more involvement of RGB. So if 0 is completely dark and completely black, does it make sense for us to have -2? -2 came out because we used a filter out here. But in the actual practical terms, you cannot have an RGB value to be -1, -10, -100, right? It is imaginary. It is not real. So what we have to do is, as soon as when we start running filters, here in the array, you will not get any negative images because these are the actual pixel values. But once we add a filter to it is when all this happens, and we have to handle these negative values, right? So any negative value that you find, all you do is convert it to positive. Look at this. F of y will become 0. Your output will become 0 no matter what when your input is less than 0, but it's going to remain the same. F of y will be y when it is greater than or equal to 0. So if you give an input of 0, you're going to get 0 as the output. If you give an input of 10, it's going to be 10. If you give -10, it's going to be 10 again and not -10, right? Anything negative goes out. So the range of the rectified linear unit is between 0 and positive infinity. No matter what negative value, infinite value you send, it's going to be tanked to 0 anyway. So 0 to infinity is the range of rectified linear unit. Make sure you remember this, because this is a very common question that might be asked in your interviews if you're preparing for an interview using this video as well, saying, hey, what is the range of rectified linear unit? And if you think that it's minus infinity to infinity, you will be wrong, because the entire point of ReLU is to make sure we remove the negative aspect of things, right? Fantastic. Now, this is super important to understand. As I just told you, right, we have a couple of pictures here with which we have a picture with a couple of pixelated values, and we have just multiplied it with a filter, and the output is giving us negative numbers. What we don't want is negative numbers. So as soon as the ReLU layer works from the convolutional layer, any negative value is brought to 0, any positive value remains the same. This is the ReLU layer. The next layer is another layer called as pooling. Pooling is done. See, whenever you're saying, hey, let's pool some money to maybe go to Goa, let's have a pool to eventually bring some money together and maybe have a party, have some fun, do something, right? So pooling is actually bringing stuff together eventually to make sure that you have one contribution, but it doesn't get really big and complex, right? So to reduce the dimensionality, whenever you're trying to multiply each of these filters, and when you keep multiplying on and on and on, your matrix just keeps growing and growing and growing. To make sure we bring it down to a certain extent where it's workable, it's very common for us to apply something called as a 2x2 filter. What you saw previously was a 2x2 filter as well, right? This filter that you see, 2x2 is basically 4 elements, 2 into 2 matrix, right? Simple. Okay, so if you're doing that, if you're removing all these values, why do we even have to pool? I am sure this data is minuscule for a computer, so why are we even going through the aspect of bringing the dimension down? Remember the concept of overfitting that I just practically showed you in the previous demo? If you do not let your, if you just let your dimensions go out of control while your model is training later, it will have so much of numbers to crunch through and run that it will get confused, it will hit overfitting, and your model accuracy is just going to go down and down and down, right? To avoid that, we have to make sure pooling is very important. Now, pooling is very important. Well, let's just have an example on the screen right now. You will see that if this is our input and we want to run a 2x2 filter on it, what are we going to do? How do we basically multiply? To answer that question, here is the answer to it, right? Now, when we say stride is equal to 1, you will see 2x2, you already know this filter. When I say stride equal to 1, all I am trying to say is, hey, just move each of these elements once, and you can see these 4 items that are highlighted here. Just take the filter, multiply those digits with these digits. What do you get? Out of these 4 boxes that you multiplied and the 4 boxes that are present in your filter, as soon as you perform multiplication operation, you get one value. You see that? We've just taken we've just taken a 2x2 matrix and brought down the value to a single value, right? This is what it means. But when I say stride is 1, I am telling it how the filter should move around. The first time the filter gets multiplied, it gets multiplied for these 2 values. If stride is 1, it means have an overlap of 1, right? So what happens next is the stride moves to the right. The filter is applied on the next couple of rows and columns. Since there is an overlap of one particular column or one particular row here, that is why we have stride equal to 1. If stride equal to 2, we would have this as one box and this has the other box, right? Pretty simple. And you can see that if we keep doing this and doing this and doing this, eventually you are going to end up with just 4 values out of the initial 8 values. Now it understands what the feature is because we have applied a filter. It knows that we're not letting the dimensions go out of hand. In fact, we're controlling it and we're doing it really well. And we've also told how the data should move, how the filter should move across our data, right? That is what stride means. Fantastic. The next thing that we're going to have to do is, once we have this kind of an output, we have to flatten it and bring it to our structured output, because our neural network has to have structured inputs and structured outputs in a way where you have to make it convenient for the network to understand why we have to submit this data in this format. That is the reason we'll actually take this particular input, flatten it out, and make sure we're just basically converting the array into one other dimension, and we are just sending it out there, right? Once that is done, you're just bringing together all these layers, right from the convolution layer to the end layer, which is the fully connected layer. We're just bringing all these features, we're bringing all the filters, all the eventual run executed outputs, and we are trying to just create a network, right? This is the step where you just bring everything together and start building and start working on your model, right? So this is what the input looks like to our input layer. After we have performed all these convolutional operators, ReLU layer, pooling layer, and all of this done, we have 4 numbers here. And once I give these 4 numbers to our input layer and it runs through the entire network, the output layer is what we are interested in, right? We are giving it numbers and basically image data, but in the output we are trying to understand if it's a cat or if it's a dog, right? We're giving it images of cats and dogs, but the images of cats and dogs get broken down in a number format, run through the entire network, and eventually give us the capability saying, hey, it'll say at the end, hey, input an image. As soon as you give it an image, it'll tell you, hey, this is a cat or this is a dog. How fantastic is this demo, right? So guys, with this, it is high time we actually jump right into Google Colab and take a look at this, right? So let me quickly open up the tab here and let's scroll a little bit down. Now, I told you that there are going to be a lot of cats and dog images out there. I know you guys are excited to see cat and dog images. So let's actually download it. It's available at this Dropbox location. So instead of downloading it, putting it on the drive, you can actually download it for a working environment, and you'll see it's a couple of megabytes, right? I think it should be somewhere around 300 MB in total, right? Okay, so this was 173 MB and this was 217 MB. So it's 400 MB. So if you're using your mobile networks to learn, just take care about this, right? So all I did was I brought all these files into my working environment. Now, if I just click on files, you will see that there are training dataset files, testing dataset files. I don't even have to split it. It's already there. But this is in the zip format. What I want is to make sure that I extract it from the zip format. That is where you have a very simple piece of code, which basically is this, guys. Exclamation unzip, and the name of the file will basically unzip it, give you all the files, inflate it, and eventually give you the data set, right? Now look at this. I have hundreds and hundreds of images of dogs and cats. Every single number you see there is basically an image of a cat, it's an image of a dog, and all of that, right? I can keep scrolling on, and eventually we will never end there, because we have so many pictures of cats, so many pictures of dog to do it, right? It says, do you want to replace the training data set? Yes, I want to replace it for all. Now, as soon as I hit that, and did it take it? Yeah, let me just hit all. So as soon as I hit all out here and hit enter, basically I'm just telling it, hey, just extract everything, put it into 2 separate folders. One is the cat folder, the other one is the dog folder, right? Now it just took a couple of seconds, but now I have thousands of images of cats and dogs here. Look, this was a zip file. This was the extracted one, right? Let's quickly take a look at a couple of cat and dog images. I am sure you guys are as excited as me. Look, we have both for the testing dataset and the training dataset, we have 2 separate folders which says that, hey, these are pictures of cats, these are pictures of dogs. Right now, we are not interested in the testing dataset because we'll only show this to our model after it has learned, so that we can verify if it has learned anything or not. Let me just click on cats and let us actually try to download 1 or 2 pictures of these cats to see what it might look like. Now, this is definitely going to take a while because it's a lot of files, right? So instead of that, let me just download these 2 files. So I'm just going to click on this and I'm going to hit download here. Now, as soon as I hit download there, it'll download it to my machine. And let me open this image right now. We can be certain, oh, this is a cute cat. Look at this. We are certain that this is a cat, right? Super. Now, let me just scroll around, find another random image and download that as well. Let me click on download here and let's check out this cat image as well, right? Of course, this is another cat too. Like this, we have thousands of pictures of cats from thousands of different angles to make sure our deep learning algorithm model understands this. Now let's take a look at 1 or 2 sample dogs and we can proceed with the model itself, right? So let's just give this a second. There are thousands of files it has to index. This is a random one that I'm picking up. I'll hit download, just scroll through, pick up another random one, hit download. Fine. We have 2 dog images as well. So let's just see what these dog images are. This is of course a dog. We can confirm it, you can confirm it, and I'm going to open this other one. This is going to be a dog again, right? So this is a dog. Now this is very confusing for a deep learning algorithm because a cat also, you can have a very furry Persian cat which might look like this. While training, it has to realize that this person's face and this person's body is not a cat or a dog, right? So it has to train for that as well. That is the reason we have thousands of images we give this data set, so that it can have a sure shot way of guessing, if it is not guessing, in fact understanding what a cat looks like and what a dog looks like, right? Again, we did it manually. Now let's just see if all our data is intact, and let's just quickly try to print 1 or 2 pictures of cats, and we can get going. And look at this is another picture of a cat, but there's so much in the background the model will also see. There is a hardwood floor here, there is a wall. The cat is not doing what normal cats do. Normal cats stand on 4 feet and do something. This is a cat which is like casually posing on the wall or something, right? So this can confuse the model. Let's take a look at a sample image of a dog as well, right? Look at this. This dog is smiling, happy. It's a very cute dog. But from this angle, you can see that its eyes are hidden because this particular breed has so much fur on it, and it can get confusing again, right? Super. Now, the next thing that we are going to do is import all the libraries that we have, right? Now, you've been seeing this word called Keras out here for a really long time. What is Keras? Keras is nothing but a very simple API that adds more functionality and increases the visibility by giving us simple syntax through which we can do a lot in TensorFlow, right? Now, Keras is super popular. It is used as an API. It is used as a packager for TensorFlow. And as soon as I click on run here, all I'm trying to do is we're importing everything in terms of Keras pre-processing. I told you, right, we're going to be using a sequential model there. A couple of inputs, couple of hidden layers, couple of outputs. This is exactly what it is. And all of these other things are all required, right? Max pooling, activation function, the actual image, and all of these, right? Superb. First of all, let's take a look at the TensorFlow version that we're going to be using. Right now, there are multiple models. There can be multiple tutorials out there which are old, which can be using an older version of TensorFlow 1.x. When that is the case, there are so many things which have changed in its syntax that can get really confusing. So guys, we are using the latest version of TensorFlow here. So I just thought I want to let you guys know that. Right now, this is where basically we are trying to give an understanding of what the model should do. You don't have to do this. You can do this at each of those steps as we did in the previous demo, but I do this here all at once is to just tell you guys about it, right? First of all, we're just saying, hey, here is where all the training data is to use for training. Here is where all the testing data is. And here is the size of each image. It's 150 by 150 pixels. Now you could have used a 4K image and you could have used a very large image, right? But that for you to download, use and upload thousands of images, it's going to take a lot of time. So we just simplify it down. Sometimes we even resize really big images to this this is a small dimension, so that it becomes very easy for the model to understand. Right now, here you will see something called epochs. Epochs we're already good with. This is basically me telling it, hey, just train 20 times for this entire data set. Next, we have the training samples and we have the testing samples. So wherever it says validation, it is basically the testing sample, right? And each of these samples get broken down into batches, and each batch, you have the 20 values, the 20 images of cats, 20 images of dogs that goes in. As soon as I run this, all of the parameters which we will require later to train the network are done here itself, right? So the next thing that you really have to understand is when we have an image width, right, you're going to be seeing something like 150 x1. Let me just write it down so it becomes easy for you guys to understand, right? So let's just say it is 150 cross 150 cross 3. You're going to be seeing something like this. Okay, the first 150 and the second 150, you understand that this is the size of the image, height and width. What is this? Right now, this is basically telling us how many channels are there for the color representation. If it is only one, and if your image is only one color, usually what do you call it? Black and white, or you call it as grayscale, right? But if it is 3, all we're trying to say is we're going to be using red, green, and blue, or it can be another combination as well, which uses cyan, yellow, and all of those colors as well. But with red, green, and blue, you can make any color that you want in the entire world. That's the the reason we have 3 channels here. So whenever you see an image which says 150 cross 150 and another 3 at the end, you might be very confused to say, hey, is this like 3 dimensions or something? No, it's basically the number of channels, and our image data gets represented as a height and a width and the channel data here as well. Look at this, we have the image width, we have the image height, and we are saying that, hey, all these images, right, cats and dogs, these are not black and white images, these are color images. That's the reason we have that as 3. As soon as I hit run here, done. What we've basically done is we're just checking the shape of the images, we're giving it correctly. The next part is where our entire model has to train, ladies and gentlemen. We're going to be using a binary classifier here to train, because why binary? What are we doing? We have cats and dogs. We have no other classes, right? We only have a cat class, we only have a dog class. So we're using a binary classifier to either call all of these or a couple of images of these cats, or all of these and a couple of these as dogs. As simple as that. Now, as soon as I run this piece of code, it is going to tell us how many images it has found in the testing data set and the training data set as well, right? So we're going to be using 8,005 images for training, and we're going to be using 2,000 images for testing. And each of these and basically all these images belong to 2 classes. One is cat class and the other one is the dog class, right? Superb. Now what we're going to take a look at is to understand what the image data generator looks like. Now whenever you're training something and you want to understand all of these images that we are actually providing the model to learn, look at this. You can see that this has been resized to 150 cross 150. Some of this might be stretched, some of these might be elongated in a way where the real cat will not look like that. I am sure that this picture is skewed, right? A cat will not look like a rectangle, and I'm sure this dog also, the image, as soon as you look at an image, you can sort of guess if the image is skewed, if the image is stretched in a very weird way, right? So usually what happens is when we resize everything to 150 by 150, there's a very good chance this will happen. So your model must also be intelligent enough to understand there that, hey, something might be wrong here. So it'll want to fix it, right? It is very simple, it is very straightforward, guys. Superb. Now this is the image that we are trying to say. These are the images that we are trying to send, the resized images. We already checked out all the layers out there: convolutional layer, ReLU layer, pooling layer, and the fully connected dense layer as we have, right? This is basically us telling, hey, use 64 neurons for this particular network. And you remember the filter size? We ran through a 2x2 filter for the example, but here in the real world, we're going to be using a 3x3 matrix as a filter, right? This is the input layer. We have a couple of layers where we'll be talking about how you can convert it. You remember when we spoke about ReLU and we spoke about pooling, when we're taking a large matrix, converting it to a small one, it's just 2 simple lines of code that tells what activation function to use and max pooling as well, right? Now, once that is done, we want to make sure everything is in 1 dimension so the data moves around in your network. That is the reason we convert a multi-dimensional array into a 1-dimensional array, and after which we have 1 output layer here as well, right? So you can have multiple activation functions or multiple layers, and as soon as I click on play here, our model basically is giving us saying this is what the output shape looks like, this is what the input shape looks like, these are the total number of parameters that we have, and of course those will be the number of trainable parameters, as in you have pictures of cats, dogs, pixels. It's going to be using all of that, and totally it has 22,431 parameters it has to somewhat train to give you an output, right? Superb. The next step is basically us doing model compilation. Compiling as in you just bring everything together, get the model to start working, right? Here we'll have to talk about what optimizer we need. We have to talk about what loss function we require. Previously we used a different loss function, but here we're using something called as binary cross entropy. Again, this is another type of loss function through which, again, as the name itself suggests, it's binary in nature. So whenever you're working on 2 classes itself, having this loss function will work really well. Why about why that this will work really well and something else might not work well, we'll have to delve right into the heart of the mathematics for you guys to understand 3-4 important graphs, understand the flow of data, understand what the functions are doing, understand the output, what happens when you input these numbers into the function. as you can already say, it can get really complex. So I want you guys to tell me which other loss function that you can use, in fact, yourself to work with this. Right now, as soon as I hit this, all I'm telling is, hey, your model is ready to execute. We know what our layers look like. We know the parameters. We know how many parameters to train. We have the data. Everything is done, and your model structure is ready to run and train. And as I told you, training happens in this place where we call model fitting. Now here, if you just see steps per epoch, right? You remember previously we just had to in the previous demo we just had to actually set it manually and say, hey, here is a number there. Now just to add increased readability, we have done all of these here. Let me just scroll up. We have done all of these here itself, right? Parameter initialization, and we're just using these variable names later down the line. That's about it. Now as soon as I go on to hit train, this is going to take some time because this is a large data set and we have 20 different epochs to learn, right? So as soon as we finish the 20th epoch, let's analyze the loss and let's analyze the accuracy as well. Alright guys, so as you can see, we've been training this for a couple of minutes out here, right? So it takes somewhere around 20 seconds for one epoch to happen. So basically we have almost at the end of 20 epochs. What I want you guys to analyze here is just take a look at how the loss and the accuracy value varies in real time, right? Look at this, it is changing. It goes down, it goes up again, it goes down, it goes up. So what your training thing, when your epoch happening is your values are being adjusted, your biases weights are being continuously being adjusted while this epoch runs, and it is just showing you the loss value and accuracy value in real time as well, right? It's not like the loss is just going down and down and down. Yes, for every epoch it is going down, but while that epoch itself is functioning, it doesn't have to say that it has to continuously go down, right? So it was at 0.55, it was at 0.56 next, and it came to 0.54. See, it's just going up, down, up, down, up, down. It's just finding a little bit of a threshold and just moving around rapidly there. Same for the accuracy value as well, right? Now 20 epochs are done. I have to zoom out for this. So let's just take a look at the accuracy values out here, right? We started out with 55% accuracy when the network trained once, but at the end of it, we have come up to 73% accuracy. Now, of course, since this took a good amount of time, we just stopped it at 20 epochs. You can have it 30, 35 epochs. And if you have a couple of minutes, you want to take a coffee break or a tea break, just put it for 50 epochs and go for a break. And while you come, it should be done, right? And of course, the accuracy, we started with 55%. The loss value started at somewhere around 0.65, but as you can see from 0.65 there are epochs where your loss has gone up, right? I told you that your loss will go down, but sometimes your network can be finicky and in a way where it can get confused if it's over hunting and if it's overfitting. So I'm very sure at the 9th epoch where it was trying something, even though the loss has come down and the accuracy has gone up, you will see that eventually the loss, the accuracy of it is not as great as that. The value loss is very high here, but we started out with 0.65. Finally we've ended up with a loss value of somewhere around 0.57. You will also get accuracy in terms of what the value accuracy is. Value accuracy started at 0.64. We would have definitely ended up at a bigger value, which is 0.7, which is basically 0.7290, right? So guys, running this for 20 epochs is this one. I want you guys to run this for 25, 30, 35 epochs and tell me what you think. Is your loss continuously going down, or is there a good chance that your loss is also going up? Now look at this. In say 16th epoch, the loss was 0.55, but in the 16th epoch, it was 0.58. Again, it went up, right? But eventually on the bigger picture, it is bringing it down, and that is what we are concerned with. And of course, the last part of it, let us print a beautiful looking graph to tell you regarding the model accuracy. Every number that you see here on the x-axis is basically the number of iterations, right? We had 20 epochs, even though it shows in 0.5 intervals. You will see the blue line is basically the training data set. Now the training data set is going to have a high amount of accuracy because it knows what it is. So testing data set is what you have to closely observe here to understand, is that it is basically what we want is it to go alongside the training data itself to tell us that, hey, it's very accurate, and if you provide this training data, it can it can be very accurate when you provide testing data as well, right? It has to be very close. These two lines are either jumping around or it's almost like a little kid scratching on these two lines, but if it is that close, it means your model is more accurate. And look at this, our accuracy went from 0.55 all the way to 0.725, and both for testing and training, model accuracy is fantastic. And then if you're taking a look at loss, let me zoom in. If you're taking a look at loss, look at this. For our training data, of course, the loss is going to be as minimal as possible because it already knows what it is. But for testing data set, again, we want to make sure our loss is kept at its lowest with every possible epoch. The highest loss we have had was somewhere around the 8th epoch. Apparently, it is 1 point something, and the lowest is somewhere around the 10th epoch, right? See, at the 10th epoch itself, there's a very good chance you have your algorithm, you have your model performing at its most accurate, and the loss slightly goes up if you keep doing it again and again. Just check it out and print the same graph again for 25, 30 values and head to the comment section. Tell me what loss values you got, right? Apart from that, we come to the last step. The last step is the most fun one, where we actually sit and send it 2 images, right? Now we will just take we have to perform prediction. So we have to take the testing data set. I'm going to provide 2 images. One is of a dog, one is of a cat, and I'm going to get it to predict if what is a dog or if it's a cat, right? So all we're trying to do is this. If your model, if your result of 0, 0, it is 1, it means that it has predicted it as a dog. If it is anything else apart from 1, it is basically a cat, right? Let me go on to hit print on this, and you will see a couple of images. Now what it's trying to say is, okay, it says it's a dog. Now this is one of the most important things you have to understand here, right? Let me just go up here. You will see the accuracy is 0.73. So for 100 images of cats, for 100 images of cats and dogs, it will only get it right 73 times, right? Now this is a chart, this is a point to show you that, hey, your network can also go wrong here, right? Now this is the image that we're trying to show, but the data that it thinks it's a dog, right? Now dog 4003 is what we want to predict. Let me just try to see if I can find that here. There are a lot of files. In fact, let us try to give it an image of input an image of a cat and see if it can predict a cat as well. For 73% of these cases, it's going to work beautifully. But yes, 1 or 2 cases, it so happens that it has some difficulty trying to figure this out. Right now, why am I seeing the training data set? I'm supposed to be seeing the testing data set. Okay, so training data set is of no use to us. So cat picture is 4002. That's what we have given here, and that's what we've predicted here as well. So what the image that we are trying to load is different. Right now, let's just copy this here and paste it here. This is the image that we want to load, right? Now we were basically importing the image of a dog and comparing it to the image of a cat. Now let's just hit here cat 4002. Let me just hit predict here, and as soon as this runs, okay, it's the same picture, right? Let's pick up something else. Cat 4012. This should be easy. 4012 is the image, the predicting value that I have to send. It will tell me if it's a cat or a dog. 4012 is what this would look like. So we'll just have to keep retraining, and we have to keep retrying. This is where it will work, and in majority of the cases it will work. 73 will work. For example, look, this is the picture of a cat. Look at the prediction. It says it's a cat. So it understands in 73 of 100 cases of what a cat accurately looks like. And you saw the first demo, the first iteration where I gave it a picture of a cat and it happily says it's a dog, right? That is where we require model tuning to such a good extent where no matter what, if your accuracy is somewhere around 85% for image classification, it is very good, because trying to get to 100% accuracy is a rabbit hole which is not achievable in all the times. It depends on extreme qualities of data and good quantities of data as well, right? So it's like a dog chasing its tail. It can go on and on and on, and you might not have anything productive as well. So I just wanted to show you an incorrect case, and I just wanted to show you a correct case as well, right? So guys, with this we are done with the practical aspect of this demo. We took a lot. Let me just quickly delete this. So I'll just hit here. Super. So we took a look at a tensor demo. We took a look at the operation. We had a wonderful understanding how this entire thing about MNIST works. This should be your first demo when you're working on, and eventually we took on a really big binary classifier to classify images of cats and dogs, and we understood that as well, right? Ladies and gentlemen, with this we have come to the end of this TensorFlow tutorial. We started this out by understanding what is TensorFlow, how it came into the picture, when was it released, who is responsible for it, why is it so popular, how can you begin using it, what programming languages you can work with it. We checked out so much to understand about TensorFlow. We understood how it got its name. We understood what are tensors. We understood how tensors work. We understood how a neural network works, the mathematics behind a neural network. We took a look at the various types of tensors that we have. We understood how to install TensorFlow, work with it, verify it, work on our small demos out we have. And of course, we took a look at two demos. One is the MNIST dataset, where we performed the handwritten digit classification and also the binary classification in terms of cats and dogs. So guys, at any moment of time, if you want to rewatch any of these, just make sure to check out the timestamps that are present on the video. Just run through it and eventually you can rewatch any of these concepts and get better at it, right? But as I told you, make sure you're coding along all of these so you have a complete clarity. Now, while you look at me doing it, it's going to be very simple and straightforward, saying, oh, okay, so this is what it does. But when you guys are actually writing your code, when you close my screen and eventually start writing your own piece of code, it can get slightly confusing, and there is nothing to be dejected about it. It is completely okay. You can avoid all of that by doing what? By doing more practice, right? So I hope you are clear with everything that we have covered on this TensorFlow tutorial. Thank you so much for watching. My name is Anirudh Rao, and as always, I'm excited to see you on the next one. Cheers.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.